Why is displacement current important for electric fields? Imagine a world where electric and magnetic fields dance together, even when no charges are moving. That's where displacement current steps in to keep the rhythm going. In simple terms, electric current usually means charges like electrons flowing through a wire. But what happens when charges aren't moving, like between the plates of a charging capacitor? The electric field changes, but no charges cross the gap. That's a tricky situation for classical current. Displacement current was introduced by James Clerk Maxwell to fix this problem. It's not actual charges moving, but a changing electric field that acts like a current. This change in electric field creates a kind of virtual current called displacement current. Mathematically, the displacement current density is the rate at which the electric displacement field changes over time. Think of it as how fast the electric field is changing in a given space. This term has the same units as regular current, making it compatible with Maxwell's equations. Why does this matter for electric fields? Because it allows the equations to stay consistent even when no charges are flowing. It explains how magnetic fields can be generated in regions without moving charges, like in a capacitor or in empty space. In electrical engineering, this concept is key for designing circuits with capacitors. When a capacitor charges or discharges, the electric field changes, and displacement current accounts for the magnetic effects. Without it, the analysis would be incomplete. Displacement current also explains how electromagnetic waves travel through space. When electric and magnetic fields oscillate, the changing electric field produces a displacement current that sustains the magnetic field, and vice versa. This mutual support allows waves to propagate through vacuum. It also helps us understand how dielectric materials work. When molecules in a material polarize under an electric field, the changing polarization contributes to the displacement current. This affects how capacitors and insulators behave under alternating currents. In practical terms, engineers use the idea of displacement current to predict how high-frequency signals move through circuits, antennas, and transmission lines. It's essential for designing modern communication systems. In summary, displacement current is important because it extends the concept of current beyond just moving charges. It keeps Maxwell's equations valid, explains electromagnetic wave propagation, and helps us understand how electric and magnetic fields interact in all kinds of media.